Now, two equal positive point charges are placed at x-axis along x-axis at plus x1 minus x1 respectively. The electric field vector at a point P on the positive y-axis is they are not asking the magnitude, they are asking only the direction. X-axis, this is the y-axis. Now I have two equal positive point, both are positive charges only. One is at equal here. If I say this is q, this also q, and this is minus x1, this is plus x1. The electric field at a point on y-axis here now. So this electric field at this location, the electric field at this location, at this point, which is this direction now, and this electric field at this location, and this is this direction now here. So again resolve into two components now here. Finally the resultant component, it will becomes what, like this, isn't it, which is along what direction, positive x-axis. The resultant field is along the positive x direction, sorry, y direction. Similar problem, little extension. A positive charge q coulombs located at 003 and negative charge same magnitude. They are asking to find the electric field intensity at on x-axis now here. Exactly similar analysis. Now I can say this is my z-axis, and so this I can say this as a positive x-axis now, where we have charges now here on z-axis. One charge, this is z-axis now here. Here we have one charge. Yes, here this is one charge. Here this is, if I say it is a plus q, if I call this as a plus q, and this I can call it as a minus q. They are asking at x-axis somewhere here now. Now tell me here, previously positive charges, I want the direction of this electric field at this location. So because of this, my electric field direction is like this now, and this is what charge, negative charge. So then the direction of electric field at this location is this direction, isn't it, this direction now here. So as a resultant of these two, the resultant field direction, it will comes like this now. So this is along what direction now here, negative z direction, negative z direction. Yes, why? Because in this component and this component will be get cancelled, the resultant field like this one. Isn't it? Now we'll see the similar type of problem one more. Now 2 point charges 5 coulombs and minus 5 coulombs are located at this thing. Asking the electric field at x0z. That means the point lies on xy plane. So in this case we cannot do directly the diagrammatically, and we'll find out this electric field at this point now here. Now here the two charges lies on y-axis, and but we need the plane, so 3-dimensional, so it is all xyz we need, but it is not directly as easy as earlier. So what we can do here, I have 5 coulombs of charge. This is located at 0, 8, 0. One more is what? Minus 5 coulombs of charge, that is at 0 comma minus 8 comma 0. Then due to this, I want to find the electric field at this point. What this point is given as a x comma 0 comma z now. So this one at this location, the electric field at this location. So because of this, I can call it as E1. Let us say this charge 1, and this is my second charge. The electric field at this location, I can call this as what? E2. So then this distance I can call it as R1 bar, and this distance I can call it as R2 bar. So now tell me this R1 bar now here, final minus initial, now this is x ax 0 no 8 ay plus z az now, and then R2 bar, which is given as what? Yes, x ax plus 8 ay plus z az. So this thing, and you can see this magnitudes of R1, that is square root of what? X square plus 8 square plus z square. The magnitude of R2 is square root of x square plus 8 square plus z square. Both magnitudes are same, isn't it? So the total electric field I can say, which is given as the field caused by the charge 1 plus field caused by the second charge now. So in general, what's the electric field at the point E, which is given as what I can say, KQ by R square into ER cap, I can say now. KQ by R square into AR cap. So now here KQ. So I can write K constant, R square is also same value now, R1 square, R2 square. So I can simply write this electric field, the whole thing, I'm simply calling it as a K, this whole thing including the K, yes, K into KQ into, I can say R bar. AR cap is given as what? KQ by R cube into R bar, I can say. So this electric field, which is given as K into Q, is what now here? 5 coulombs of charge, 5 into R1 bar. How much is R1 bar is? Yes, this is x ax minus 8 ay plus z az minus 5 into what? X ax plus 8 ay plus what? Z az. So simplify this thing, this is 5k into x ax minus 8 ay z az minus 5x into ax minus 5 cancel, 5 we have taken outside now. And this is minus 8 ay minus z az now. Now check for cancellation now here, x z az. So finally we'll say this electric field is what it is, 5k into minus 16 into ay now. So resultant electric field is what I can say here, negative y direction. Negative y direction. So what's the option now here? Negative y direction. Like this, we need to approach for this type of analysis. Right. Next problem. Now see this thing here. There are three charges which are given by Q1, Q2, Q3 are given. The field due to each charge at point P in free space is given like this. The total field at point P due to all the three charges. What? Simply superposition, summation. So the electric field